So, a few elements such as gold and copper have been known for thousands of years, since ancient times. Yet, only about 13 have been identified by the year 1700. So, as more elements were discovered, chemists needed a better way to organize these elements. So, chemists used the properties of elements to sort them into groups. And one of the first attempts was by this guy, J.W. Dobereiner. He arranged elements into triads, or groups of 3 elements with similar properties. The attempt to organize the elements got a little better with Dmitry Mendeleev in the mid 1800s. He was a Russian chemist and scientist and teacher, and he arranged elements in order of increasing atomic mass. And this created the first periodic table because the properties periodically changed as you went across the table. So here's what his table looked like. We've talked about him before and the brilliance of this organization method. Now it's not the table we use today. The better arrangement that we've agreed upon was invented by Henry Moseley in 1913. He was a British physicist and he arranged the elements according to increase in atomic number. And here's Henry Moseley in his table. It should look familiar. This is the table you have in your reference table, more or less. So his table, when you arrange the elements in order of increasing atomic number, you get what's called a periodic law being present, which is a periodic repetition of physical and chemical properties. So on its most basic level, if we just follow, let's say, a period across period 2, we start with lithium, which is a metal. As we move across period 2, we get a metalloid and then nonmetals. And then we repeat. Once we get to period 3, we have metals, and then a metalloid, and then nonmetals. And over this repeats. And there are other properties that repeat in this similar periodic fashion. So the modern periodic table is arranged in periods and groups. So the periods are labeled for you on your reference table, and they go down the left side here. You can see them, period 1, 2, 3, 4, 5, 6. Now the 6th period is also shared by this first column in our lanthanides series, or our rare earth elements, because if you follow the numbers, this is 57 lanthanum, and then it skips to 72. All those missing numbers between are right along this top row here. This is also the 6th period. And then we have the final 7th period. And again, we have a little cutout here on the bottom. We call this the actinide series along the bottom, which contains all the missing elements between 89 and 104. The groups go along the top. They're labeled for you as well. There's a couple of different methods that are used in periodic tables to label the groups. Some have numbers and letters. Some just have numbers. We'll be using the one the New York State Regents gives you, which is just numbers. So they go across the top, 1 all the way through 18. So the modern periodic table is arranged according to increasing atomic number, thanks to Henry Moseley. And when the elements are arranged this way, there's a periodic repetition of properties, which we call periodic law. The modern periodic table is arranged in periods, which are the vertical or side-to-side rows across the periodic table, and groups, which are the horizontal or up and down columns of the periodic table. That's it for this video. In the next video, we're going to talk about the organization of the periodic table and some more information that you can get from that.